Hello everyone, welcome to this video. And today's topics is drawing to the screen. Actually not really drawing, we're more going to just clear the screen to some default color. What does that mean to clear the screen? Well, actually once you draw everything, let's say that your game is running, and on the start of each frame you kind of want to clear your content from your texture, right? From your screen you want to clear the content. And that's what we're going to do this video. So for that, actually I'm missing one slide, but we're going to need to have a couple of objects, and one of those objects is render pass. So it's an object that is used to set up target for rendering and state of images to be rendered to. What does that actually really mean? It's just render pass as a target. It means it just contains some information about the pass, and it also contains reference to the texture that we want to draw to. That's it. So in our example, second point, we want to draw to surface provided by client, but might in future draw to off-screen texture. So that really means here we can read it, okay, draw to the surface or texture that's provided by our windowing system, and that means, and later on we're going to present that texture. So in our case in code, we're going to get the texture, right, from the window itself, and then we're going to draw to it, and then we're going to present it to the screen. All right. It also stores all drawing commands and rasters this to its core attachment. So this really means drawing to our window. WebGPU is a raster engine for those who don't know it, but basically it means it's kind of raster graphics, right? Fill in pixels, right? Draw shapes and then fill in pixels of those shapes. That's what raster engine does. It also contains depth stencil state. Depth state, we're going to cover it in future. It just means we kind of need some way to perceive depth information to know which objects are in front of each other, and stencil state is used mainly for masking. You can mask a region of the screen and then you're not able to draw to it. So usually it's kind of used for some kind of special effects and stuff like that. Next object that we're going to cover is WebGPU command encoder. It actually is used to record and encode GPU operations. That means whenever we draw something, right, we want to draw some triangle, some model, some mesh, we kind of have to record that for the GPU, and that's the curious part, because it's not yet submitted actually to the GPU, so it's just the CPU part. We kind of encode that and have a chunk of memory where we store our operations that we want to do later on. So what can we record? We can record previously mentioned render pass, right? So if you want to draw something to the screen, we can encode compute pass. If you want to do some, if you want to use your GPU as an accelerator for some code that you would usually run on the CPU, usually machine learning, stuff like that, and maybe particles as well, physics as well. Then we have transfer operations, but that just means copying resources, such as usually we might want to copy texture to another texture, or region of the texture to another texture. Buffers we're also going to cover in the future. Buffers are just chunk of memory that's going to go to the GPU, usually our information about the model, where the vertices are, what the normals, texture coordinates, stuff like that. And when we finish with GPU command encoder, we can call finish, and then we get command buffer, and that's our actual chunk of memory that's going to be passed on to the GPU. So WebGPU command buffer, complete sequence of commands that can be submitted to WebGPU queue. So we kind of have to cover queue next. Created when we finish with WebGPU command encoder. So that means there is this finish like method or function, and then we kind of get this command buffer. WebGPU, it's actually WebGPU. So the GPU has its queuing system, right? So that it knows when to do stuff. So we kind of use these command encoders to encode commands. So for example, one of the commands that we can encode is just draw triangles, right? Draw something to the screen, draw this model, and then with these command encoders, we kind of have to submit them to the queue, right? So that's what the queue is used for. So in the next slide, we're going to see more on that. but also it just provides convenience method or functions for writing to buffers and textures. Also, we're going to cover it later when we actually create buffers and textures. And here it's just small overview of how it is used. So it's probably better to read it from bottom to the up. So first of all, we create kind of render paths, right? We already mentioned render paths. So what do we use render paths for? Well, for drawing to the texture, right? And what do we draw with? Well, we usually are going to draw to the surface texture. We could draw to off-screen textures. That's kind of useful if you just want to draw to some texture and then use it later. Let's say you want to create a height map, but it's also used very often for post-processing. Post-processing usually means you might want to have multiple textures that later on you're going to combine. So sort of like Photoshop, where you might have layer over layer over layer, and then draw to depth and stencil attachment I already mentioned. So those are also textures, right? So depth attachment is a texture that contains depth information, and stencil as well. Just contains basically bits that can be drawn or not to. Then when we're done with the render pass, we have created our render pass from command encoder. So we can create a render pass, compute pass, bleed command. Bleed command is what I mentioned. It's for copying texture to texture. So these transfer operations. What we're concerned with mostly is going to be render pass, and we might cover compute and bleed a bit later on. And once we're done with our render pass, so I forgot to mention here, actually command encoder can have multiple of those, right? It can have multiple render passes and stuff like that. But once we're done with it, we're gonna just submit it to the queue, right? So the queue can have multiple command encoders. And that's very often used if you're copying resources a lot. And the queue just says, okay, if I execute this command encoder first, let's say that it refers to this. So we have command encoder, it has its render pass, and then we execute that render pass and draw something to the surface texture. But second command encoder might have another render pass, but it might draw to off-screen texture and stuff like that. So you can combine it in any way you want. What's important is your graphics card, right, needs to know in which order to execute what. And so that's what the queue is used for. Here is our code from the last time. And I just had this basically screen, which it might be different content depending on the system, but it's not really important. What's important right now is for that system, we had this surface configured. And what the surface is, it's kind of like surface of this window. And what's important, it's going to provide us a texture to which we can draw to and then present to the window, right? So it's all going to make sense in the end. But before we even start, I just forgot one thing here in our configure surface configuration, and that's the usage of it. And for the usage, we just want to say actually render attachment. This we're going to work more on the usages a bit later on, but for render attachment, just know that with WebGPU, you kind of have to set the usage of a texture. And render attachment means it's actually going to be rendered to that texture. So we might have read-only textures, like when you have some asset that you want to read in, but this is kind of like a write texture, but as a render attachment, right? So we just kind of have to set its usage, and then we're actually good, and we can start with our render method. And here I'm just going to actually have two functions. One is going to be before render, and the other one is going to be after render. And why am I doing that? Well, before render is actually going to prepare our resources to which we can draw to, which is going to be our surface texture basically. And after render, I just want to submit all those commands to the queue and clear up resources. That means release them, delete them, dispose of them, whatever you want to call it. So first, let's start by creating our objects. And here, what's the first thing that we're going to need is actually that queue, and we can put in queue here. the next, what do we want to put in the queue? Well, we want to put command buffer, which is created by command encoder, right? So we can create encoder, and I'm going to call it current command encoder, because I think we're going to use only one, this is current because we're going to be getting rid of it on after render method. So what do we put into command encoder, right? What do we encode there? Well, we could encode render pass or drawing code. The render pass is responsible for drawing. We could put compute pass encoder or duplicate commands, but we're going to use it for render pass encoder. So it's called something render pass encoder, exactly. Current render pass encoder, that's fine. And what do we need for render pass encoder? Well, we need surface texture. So this one is not a pointer. So this one is actually an object that's going to contain a texture. Can I showcase it here? So if I say surface, no, I'm going to showcase it later. But how do we access that surface texture? Well, we access it through texture view. So I'm going to call it surface texture view, and be mindful this one needs to be a pointer. So only one that isn't pointer is surface texture. The other ones all have to be pointers. So let's get started with that. Well, first things first, we're going to need that queue. And how do we get it? Well, we're going to say, where are you? WebGPU, device get queue. We pass in device. We did already create device last time. And here, after the queue, we kind of need to create that command encoder. So we can say create command encoder is WebGPU. Command encoder create something, create command, here it is, device create command encoder. That's the function. We need device, and the descriptor for command encoder we can only really put the label. I don't care about it, so we're just going to pass it now. Then we need to create a render pass encoder. So I can say render pass encoder, WebGPU. Then command encoder, because this is the method of command encoder, right? We put the render pass encoder actually belongs to command encoder. So we kind of need to do, what do we need to do? Command encoder, begin render pass. That's the method. And here it takes in command encoder, and then the descriptor, we're actually going to have the descriptor, and we're going to fill it with a lot of details. So let's do that, render pass descriptor. Okay, that's good. So what do we have? Depth stencil attachment we don't care about. So what do we care about? So we can put in label. Do I want to put it? No, we can, it's not necessary really. But do we need color attachments? Yes, we need color attachments. So we can create render pass color attachment, and I'm going to call this color attachments as array, and it's going to be pointer. So here is the tricky part. We don't want this to be heap allocated. We just want to allocate it on stack. So we can do that with stack alloc, and then press render pass color attachment, and that's a 1. Why? Because this function actually will require, I think we need to pass here. Actually it just works with pointer. I thought we need to pass a pointer to array of pointers, but regardless, we can leave it like this because in future we might have multiple color attachments. And what does this stack alloc mean? So it's kind of saying just allocate this on stack instead of on a heap. So just for those who don't know it, in C# you kind of have two kind of memories. So you kind of have stack memory. So let's just say here stack. And then you have a heap, which is huge chunk of memory somewhere, which is called heap. And usually in C# when you allocate an array, you're going to have kind of you're going to have value here that points somewhere to the heap, right? And there is a chunk of memory that's used for an array. But when you use stack alloc, actually all of the array's values are going to be somewhere on the stack. So all the values are here on the stack and not on the heap. But what's the difference, right? What's the difference here? Well, with the stack, when this stack exits the method, this is going to be cleared automatically. But with the heap, actually the garbage collector runs every now and then if this is not referencing anything anymore, right? Then the garbage collector will say, okay, I'm going to clear this up, and the garbage collector will get rid of this. So sorry for the kind of bad drawing, but that's what it is. So it's kind of just going to live during this method, basically. All right, so we can say here for call attachments count, we have to pass in count because we're just passing pointer. We also need to pass in count. But now let's go to our call attachments and then say 0. So what do we need to pass here? We need to pass view, and we haven't yet created a texture view, so let's do that. So I'm just going to say here WebGPU surface, surface. Which one do I need? Aha, surface get turned texture. So we're going to pass surface here, and then, right, we have created surface texture. And now you can see that surface texture actually holds our texture, right? But now we need to create that view because here we need to pass view of the texture. So let's do that. Current surface texture view. So we're going to say view texture create view. And here we can paste that texture. So surface texture dot texture. And do we need texture with descriptor? I don't think so. I think we don't need it. So we have it now. Let's paste it in. And I'm just going to say here a bit, do this Q command encoder surface texture. And then here, all of this is just going to appear in the pass. Encoder. Okay, so additional properties that we need. So we're definitely going to need store up, load up. So load up kind of answers what we do with the texture when we load it in. So here we're just going to pass load up clear. So essentially at the beginning of frame, right, when you start using the texture, what to do with it? Well, we want to set it, we want to clear whatever was drawn to it previously in previous frame. So it kind of answers the question, okay, what do I do with it in a new frame? We want to clear it. To what do we clear it? Well, we clear it to our clear value, which is just a color. And here I'm just going to use some nice color, which is this cyan blue. So basically 0.1, 0.9, 0.9, and 1.0. And then we have just one more thing. So store up, what do we want to store in it? Store up, well, we actually do want to store. So it kind of, what do we want to do with storing? We want to store. You can also discard if for any reason you have some texture, right? And you have it and you don't want to draw anything to it, you can use discard. So I'm not sure for the reasons. I'm pretty sure that there are some valid reasons for it. Not sure which ones. But going further, so we need to paste that render path descriptor. Okay, that's cool. So now we have all of this. Now just in after render, what we actually need to do is present that surface, right? So we're going to do it like this. You present surface present, and we just pass in that surface. And I think that might be even it. Let's try it. Right, it's a bit slow. It's slowly compiling, and I have an error here. Aha! Oh, my bad. my bad. I cannot just present the surface because, right? We have created render paths, but did I put it in a queue? No, I haven't. So I need to do that as well, right? So let me do that quickly. So what I'm going to do is this before I present the surface. Pass encoder, end. So we're ending our render pass. So we pass. So end render pass. Then what do we have to do? Finish with command encoder. Right? And we pass in current command encoder for the script that we don't care about. But look at the result. It's that command buffer that I mentioned. And the command buffer, we store it into the queue. It's a pointer. So put encoded commands to queue. All right. Then let's just put everything into the queue submit. So what do we need to submit? Queue that pointer to command buffer. And no, sorry. The first argument is the number of command buffers because there can be multiple ones, right? I mentioned that we can store into queue multiple command buffers, right? Or command encoders. So that's what this specifies. It's actually saying, okay, there is just one. And here it's bugging me because it needs to be pointer to the pointer because this can be array of command buffers. So you just kind of have to use this. If you take a look at the arguments, it kind of says pointer to the pointer. So usually pointer to pointer in C means an array of pointers, right? Okay, that's it. Maybe now we're actually going to get something almost there, not quite. Let me see if I'm missing something. I'm presenting the surface, submitted the queue. That's interesting. Maybe I just need to rebuild it. It might not be idea though. It might not be bad idea to call this as well, actually. So here we're going to say to do draw here. There we go. There we go. Cool. So we have our window, which is now cleared to whatever you paste in here. If we say here, you can now experiment with it to see what you're going to get. If I just say load, nothing happens, right? Because we're not clearing that color. So it kind of needs to be clear if you want to clear it to that color. And yeah, that's it. You can probably change the color here. Not that much to do. One thing that I want to actually do is just because we have allocated all of these resources, right? The texture view and stuff, but we never release them. So I usually like to dispose of resources at the end. And here I'm just going to say present surface. So the present surface, actually, what does it mean? It kind of just draws our texture, which was bound here in this color attachment. It kind of just presents it to the screen. Okay, let's dispose of the resources now. So a queue we don't need to dispose of. Let's go from the smallest one or the latest one to the current one. So I think the texture view is first one to get disposed of. So view, texture view release, surface texture view, then we can release of the surface texture release, surface texture dot texture. What's the next one? Render pass encoder, right? Pass encoder release. Then we have command encoder. encoder release. But before that, we actually have command buffer. Can release command buffer, and the last one is what? We don't have the last one. That's it actually. That's it, I think. Okay, good. So just to quickly recap, but basically the queue is responsible for queuing our commands and sending them to the GPU, right? In order so that GPU knows to execute what and when. How do we do that? Well, we actually do it through the command encoders, right? When we call command encoder finish, then it creates a buffer, right, of commands, and then we submit it to queue, right? Okay, good. So the next step is with current command encoder, we kind of have to say, what are we going to do? Are we going to render? Are we going to do compute pass? Are we going to do bleed commands, which is just copy some stuff around? In our case, we want to do rendering. So for rendering, we kind of create render pass encoder, right here. But we kind of need to describe it, right? We need to describe our render pass. And our minimum example just contains color attachment. It contains surface texture, right? So this is the texture that was provided to us by Windows system that we can draw to. Then we just cleared it to some value, and we kind of use store. Store is important once we start drawing, right? Because we want to store to the texture. And then we just use that surface view to actually create that texture view. And that's it, right? And here we just finished everything. And yeah, that's kind of it. I mean, that's the low-level program for you. It does have a lot of steps. It's not that hard once you get into it. With that said, we're done. For the next time, what I want to do is actually to draw something on screen, right? Not just to clear it, but to actually have some kind of triangle. And triangle in computer graphics is kind of hello world of, well, computer graphics. So we're going to do that next time. So if you enjoyed this video, maybe like, subscribe, leave a comment, and until next time.